Let's take a look at that question that's probably been burning inside your brain. What is a proof? Okay, a proof is a roadmap. A proof is a set of step-by-step directions that take you from point A to point B. A proof is a validation of some claim. Okay, a proof answers the questions, well, why? How do you know that that's true? That's what a proof is. Okay, let's quickly explore that idea of the roadmap. So here's how a proof is. A proof gives you a starting point. Where are you starting from? So in my roadmap analogy, I'm starting at Hoffman Estates High School. A proof will tell you, well, what's your end game? Where are you going? I am trying in this example to go to the Schaumburg Library. So here's clearly our map. Okay, that's my diagram, so I can see everything. I can see the connections from here to here, here to here, here to here, whatever. Okay, but a proof is a way of writing out those directions. So when you have somebody directionally challenged like I am, they're going to need these step-by-step directions to tell them exactly how to get from Hoffman to Higgins or to get from Higgins to Roselle Road. If I skip and just say, go from Hoffman to Roselle Road, okay, somebody who's not good with directions, they're lost. It's the same idea in your proof. Okay, you have to get every single step and you cannot skip one or you've lost the person trying to follow your roadmap. Okay, so here's your first glimpse at an actual geometry proof. So what are we going to see? We're going to see a given statement. This is something that we know to be true based on the given diagram. Okay, the proof statement, this is your end game. This is where you're trying to go to. So this is your Hoffman Estates High School, and this is your Schaumburg Library. Now, a proof has two columns. The first column is your statements column. The second column is your reasons column. This column gets specific info to the diagram. What does that mean? That means you're getting specific numbers and letters from the diagram in your statements here. So maybe we say angle A is congruent to angle B, or segment BC is congruent to segment AD. Okay, it's going to be specific numbers and letters to this given diagram. Now the reason side over here does not get to be specific at all. Okay, this side has to be general. What does that mean? That means we're going to use theorems and definitions over here. If two segments are perpendicular, then they form a right angle. Or if a point is the midpoint, then it divides a segment into two congruent segments, and things like that. Now notice I didn't say, oh, point B is the midpoint, therefore it divides. No. We don't get to use any specific letters or numbers from the diagram here. I should be able to cover up the statement side, and whatever is written here could go to a proof, go to a diagram with different letters, and this would still apply, and nothing here would have to change. Okay? The statement side gets to be specific, the reason side has to be general. Okay, so now that we have an idea of how a proof looks and what goes on the left side and what goes on the right side, we need to work on the flow of a proof. For most people, this is the hardest part of a proof, is to get the flow of it just right. Okay, so here we go. We are going to take a look here at my given statement, and whatever given statement or statements I have go into step one 100% of the time. The reason for step one is given. Okay, this entire first step, non-negotiable, no thinking involved, you just copy it down. So we are laying out what was actually given to me in a proof. Okay, fine. Then we have to build on this. So we have to look at this and say, okay, well, if this is true, what else is true? Okay, so maybe we come up with the fact that, well, if A is true, then B has to be true. So look at what I've done. I've said if the step previous is true, look at the connection, I've color-coded it for you. If that is true, then here's my new conclusion. Okay, this conclusion, whatever B is, I'm going to write here on the statement side. So now I was just able to come up with my statement for step two. If step one is true, okay, if whatever the given is, okay, is true, then it leads me to the next step. So this is my next claim, and this is my justification of that. Okay, so then we look at step two and say, well, gosh, if B is true, then what? Okay, so if B is true, then C is true. So here's my claim. I'm claiming that C is true, and look at how this works. The if always correlates to something up above. So if you're going to say if B, well then B better be established up there somewhere. And the then has to match the current step you're on. So the then goes straight across. Whatever you say, then C's across from it. Then B's across from it. The then has to be in the same step. I know I keep repeating that, but this is super important how proofs work. Okay, the if goes to the step above or two steps above or something previously established. Okay, the if always correlates with something above it, but the then correlates directly across. So now we can look at this and say, oh great, now we said step C is true, or whatever this claim is now true. So now step 4, and again, look at, I'm doing the reason side first. I'm saying, well, if this is true, then what does it lead me to? So now because we knew C was true in the previous step, if C was true, it leads me to then D is now true. So here in step 4, I'm claiming D is true, and this is my justification. Because if this was true in the step above, or because this is true in the step above, it leads me to saying, well, now this is true. So we're going to repeat again. We're going to say, well, now if D is true, and I just claimed and proved that it was, so now if D is true, then what? We have to keep repeating this process by saying A, and then if A, then B, and now we said B, so then if B, then C, so now we've got C proven. If C, then D, that gets me D. We keep going in this manner until we get to the proof statement. Once we're able to say E is true and we are able to justify it, then we're done. Hopefully you see the flow of this proof, but one more time, I'm going to reiterate a little bit here. So if you're good, pause the video, stop the video, but just really see that how the if, and I color coded it. Okay, see how the if always correlates to the step above. And it could be 2 steps above, it could match back to something else that was given, that's fine. But every if statement here has been justified, has been established previously in the proof. The then directly correlates with the step you are on. So look at the flow here. If A, then B. If B, then C. If C, then D. If D, then E. Do not flip things around and use the converse. Don't say if B, then A. You have to make sure that the order of these statements are the exact order that you want them in. And there you have a proof.